Okay, so what's going on with this first one? What did we talk about yesterday when you don't see a subscript? Base 10, right? So that's the one I told you could put in your calculator, right? So you could put 4 log of 1,000 and get what? What's the answer? Anybody? 12, thank you. Right? Because this is 4 times, right? So that's 4 times, and then you can put that in the calculator. If it's the base 10 log, the common log, that's the one, like I said, it's the log button in your calculator, right here. So you can just go log of 1,000, and it'll be 3. Close it off, though, remember. There's the 3, but you gotta go times the 4 then. Okay? But here's what I taught you to do it, how I taught you to do it mentally. Right equals x. So this means 10 to what power is 1,000? That's what we're thinking in our head. Okay? And 1,000 I can write as 10 to the third. Any, tens, hundreds, thousands, 10,000, and so on. If I got a 1 and zeros, it's 10, and then that whatever many zeros there are. Okay, so this part here means 10 to what power is 1,000? Okay, so it's 10 to the third. The 4 we just multiply by it then. So you could do that one mentally as well. This one we're doing mentally. Okay, still. All right, so I'm thinking, remember, we write equals x. So I'm thinking, the 5 I'm going to worry about later. But this is 13 to what power is 169 to what power? What's cube root's power? Exponent. Anybody? 1/3, yeah. We had one that had the 5th root yesterday, didn't we? We said it was 1/5 power. All right, so this is the 1/3 power. That's the same thing. The cube root of 169 is the same as 169 to the 1/3 power. Okay? Now, what we want to try to do, like we did here, is use the same base. So, does 13 go into 169? Yeah, it's 13 squared. All right? So, I could rewrite 169 as 13 squared. What am I supposed to do with the 2 and the 1/3? What's the rule for exponents there? If it was negative, we'd flip it. But if I just got a 2 and that 1/3, what am I supposed to do with that? Not working up there. What's the rule? Add, subtract, multiply, divide. Multiply, yeah. Okay? So I'm multiplying 2 times 1/3, which is 2/3. So here's the problem. So what's x got to be for those two sides to be equal? 2/3. So remember, we have this 5 out front. So this is 5 times 2/3. So it'd be 10/3. Or I think that's 3.3 repeating the fraction of the decimal. Let's do it mentally. Today I'm going to show you how to do it all in your calculator. That problem. Okay? But I just wanted to do the mental stuff yesterday to get you to understand what's going on with those logarithms, what it means. You guys did a good job of rewriting both ways yesterday. So hopefully, but most of you did your homework, so you didn't practice. Okay, we did 4 to 40 by 4s, right? So number 4 was rewriting it. It's a logarithmic problem. You had to rewrite it exponentially, just like we did this one. Okay? So the exponential problem is 4 to the third equals 64. All right, let's look at number 8, because that has that ln. All right. So here's the problem in the logarithm. Natural log of e squared equals 2. I always do capital L because it looks like IN when I use small l, but most of the time it will be a small l in the book. All right, so natural log of e squared equals 2. All right, yesterday we said natural log was the same as log base e. All right, so yesterday we had a rule that said if this and this were the same, what happened? They canceled. That's how it got to be the 2, right? All right, so the exponential problem here is e squared, e to this power, equals this number, which was e squared. Okay, so that's the exponential. Number 12 is another one of those natural logs. Okay, just so you get an idea. Here's the problem in logarithmic form. And, you know, what we did yesterday, we had the log part was on the left, like this, and the number was on the right, okay? So again, this base is what? Since it's ln, e. So e to the 1/3 equals the number, which is that. So that's our exponential. So whatever the base is goes to that exponent equals whatever that number was when you rewrite it exponentially. Okay, 16, it's an exponential one. We're going the other way. So this was 10 to the 0 equals 1. So it's log, what's the base? 10. Do I need to write the 10? I don't have to, but you can. Of the number equals the exponent. Okay, so you can do log base 10 of 1 or just log of 1. Because when we don't write the number, that's base 10, we're supposed to know that. Okay, number 20 was another 10, base 10 one. 100 equals 10 squared. So it's log base 10 of 100 equals the exponent, which was 2. Right, that's what logs are. We said that yesterday. That's the exponent. Logs are the exponent that you're looking for. 24, 3 to the x is 47. So it's log base 3, whatever the base is, of the number 47 equals the exponent, which was x in this problem. Coming back, we did it yesterday, hopefully. We didn't practice last night, most of it. Okay? And then the rest of them, we're trying to do it without a calculator. 24, 28. Log base b of 1. Okay? All right? So, again, I always write equals x. So I know what's on the other side. All right? So I always think about it exponentially. B to the x power, b to what power is 1. Okay? Or we had a rule yesterday. Whenever that's a 1 after the log, what's the answer? 0. Right? Anything at the 0 power is 1. So our answer here is 0. Okay? 32. Might as well finish it up. We got log of 1,000,000. Again, just write equals x. The base is 10 if there's no number there. 10 to what power is 1,000,000? Well, how many zeros are there? 6, so the answer is 6, 10 to the 6. And again, that's one though. I told you yesterday, you can just put it in calculator. You put log a million, it'll hit enter, it'll be 6. 36. Oh, I don't need what equals yet. Log base 5 and 125 squared. Remember, equals x. All right, so we're saying 5 to what power is 25 squared? All right, well, 25 I can write as 5 squared. What did we just say we have to do with those 2's? We just said we had to multiply them, right? So what's the answer? 4. Okay. I don't know if we did that rule yesterday. No, we didn't. We're going to learn the rule today about when we see this. And the last one was one like that warm-up with a square root, or a cube root actually. Log base 6 of the cube root of 36. So log base 6 cube root of 36. Remember, we just think equals x. That's what we're looking for, what the answer is. So 6 to what power equals the cube root of 36? Well, we want to write 36 as 6 squared. Now I got that same base. We want to write cube root as what exponent? What fraction? Cube root? 1/3. And then just multiply the 2 times the 1/3. That's 2/3. So since I got 6 to something equals 6 to 2/3, this something has to be the same. 2/3, that's the answer. Or 0.6 for cubic. Questions? Tommy?
Number 36 was 125, not 25.
Oh, put the wrong number. All right, so that's going to change something there. All right, 125 is 5 to the 3rd. 5 times 5 is 25 times 5 is 125. So then I got to go 5 to the 3 times 2, 6. So that answer is actually 6. My bad. Thanks, Tommy. Not 4. Okay? This making sense to you guys? Are we even paying attention today? Hope so. All right, so some rules today. All right. You know, when we had like, x squared times x to the 4th, we added the exponents, it was x to the 6th, right? When the bases were the same. Okay, so when you have logs with the same base, and you're adding, you can condense it or simplify it into a single log by doing what with those 2 numbers that came after the log? Multiply them. Okay? So what we're going to do is we're going to get a logarithmic problem that's addition and subtraction and stuff. And we're going to condense it down into a single log. We're also going to take a single log and we're going to expand it. Okay? So when you have addition of logs and you want to condense it to a single log, you can multiply the numbers that come after the log to condense it. Okay? If you're going the other way, if there's some things you're multiplying, you can add them as you expand it. Okay, so we're going to rewrite logs by expanding or condensing. So one of the rules here, addition you can multiply. If it's subtraction, what are you gonna do with it? Divide. Okay, so if you have two logs you're subtracting, and they will always have the same base. For this to work, the bases have to be the same. And they will when we do these. If you want to condense a subtraction one, you'll divide the two numbers. Or if you want to expand a division one, you're going to subtract the two numbers. Okay? So, just a couple rules that we'll use. Here's another one. You know, we just had that one where we had like 125 squared, right? The one that Tommy told me to fix. That 2 was out there. If you have an exponent out here, you can move that exponent out front of the log and multiply it. All right, so this is log based, kind of hard to see, they're kind of small. But this is saying log with some base of a to a power equals that exponent, that power, you can multiply times that log. All right, that's what that's saying. Okay, so we could have taken that 2 that was up there on that 125 in that problem and moved it out front. And then does the multiplication after. All right. All right, so if I have two sides of an equation are equal, I can take the log of both sides and they'd still be equal as long as I use the same base. And since we have base 10 log in our calculator, that's the one we will use. Or if it's base E, we have that in our calculator also, natural log. All right, so if I got two logs with the same base that are equal, I can say whatever those things that come after the log are equal. That's just common sense. All right, this is the one you want to remember, though, for sure. I'm going to remember all of those, but this is the main one. This is the one that says we can do all of these in the calculator. Okay, it's called the change in base formula. Okay, so no matter what this base is, we're going to change it to base 10, to the common log. You know, they changed this base 4 to base 2s. All right, we're just going to change it to base 10. So if I got this problem, log base 4 of 8, we're going to go in our calculator, hit the log button. Whenever you hit the log button in your calculator or natural log, I got to put a number. All right, there's that left parenthesis. You need to close it off, all right? So the bigger number, the 8, stays in the top, and the base number stays in the bottom, or you can think of the basement, right? The basement is usually under the main floor, right, Mason? Okay, so whatever this little subscript number is, it goes down here. Okay, and that'll give us the right answer. So if we go back to the ones we did for homework there, that we were doing in our head, okay? Let's do this one. This 36 one. All right, we just learned that we could do that and say it's, or right here, I guess, is what I'm thinking. 2 times the log base 5 of 25. So with this change of base formula, I can go 2 times log of 25 divided by log of 5. We got 6, remember? Or it's supposed to be 125, right? Sorry. Okay, so watch. Let's clear that out. 2 log 125, close it off, divided by log of 5, close it off. The answer we got was 6, right? Okay, so that change of base formula lets us do all of these with our calculator. So that's the one you really want to remember, because you're going to use that a lot. Okay, so that's the one everybody likes the most, this one. Okay, so if we did that problem there, log of 8, close it off, divide by log of 4, close it off. We'll get 1.5. Now, we'll get some decimals, that's okay. Nothing wrong with it. All right? All right, so expanding. This is multiplication, so what could I do to make it into 2 logs, since it's multiplication? Do addition, right? So, I can say this is log, and the base part stays the same, log base 5 of x plus log base 5 of y squared. Now, when you expand, they don't want any exponents on our variables. So how do I get that exponent out of this spot? What did we just learn? Or could I move it into the front of it, right? So to get this fully expanded, this is log base 5 of x plus 2 times the log base 5 of y. It's okay to have numbers out front. They don't want us, when we have it expanded, any exponents to be left. So we just move them out front. Okay? If this was division here, what would this have been? I've just done subtraction. Okay? That's all they want us to do. We don't have to find answers. Now, if we had numbers here, you know, if this was actual number, we would actually do that. Okay? But there were no numbers, so we just go ahead and do that. Here's another one. All right, so we got natural log. All right, so we're going to use ln when we do this one. So this is multiplication, so what do I do with these two? When I expand it, what do I change it to? Come on. Multiplication I'll change to what? Addition. This division then of the z cubed, what am I going to do? Subtract it. Okay, so here's what I'm going to do. Keep the same base, so it was natural log plus natural log minus natural log. We're not allowed to have exponents, we're not allowed to have radicals when we do this. Okay? Now, what exponent is that? What do I do with the 1/2? Come on. What do I do with the 3? What am I going to do with this 1/2? Same thing. Can I simplify any of those? Or is that it? LNE is what? Remember, ln is the same as this. So what's log base e of e? That's what this is. What happens to those? What did we say yesterday? They cancel. If everything cancels, what number do we put? 1, not 0. 1, right, Connor? So, to get full credit on expanding this one, it would have to look like that. That's what it started out with. We expanded it. So sometimes you'll be able to simplify the log. So that was natural log, which is base e logarithm. All right? The other thing we're gonna do is we're gonna look at something like this, and then I want you to make it into that. Condense it. All right? So since that's out front, where could I move it? To the exponents, right? So this is ln of x squared plus ln of x plus 4 to the 1/2. Okay? When we condense, they don't leave it as fractional exponents. So what root is 1/2 power? Square root. Very good. I still haven't condensed it to a single log yet. If it's addition, to condense it, I'm going to change, do what with these two things? Addition is multiplication. Multiplication, when we expand, is addition, right? So this answer would be ln, natural log of x squared times x plus 4. So this is what it started out as. That's what it is, condensed to a single log. Okay. We didn't really do this last week. This is something new that you need to be watching. Questions? Am I going too fast? Mason, you're having trouble keeping up, huh? All right. So, first thing I look for is numbers out front. So nothing was out front, so I'm just going to leave this one the same right now. But I'm going to move the 3 to the exponent, and this one I won't change either. Okay, no fraction exponents, so I don't have to make any radicals. When I put these two together, what happens to this and the y cubed? Because it's addition. Multiply. What happens to this one, though, since it's subtraction? Divide. So I'm going to just make it 1 x squared minus 4 y cubed divided by x minus 2 cubed. Now, this is tricky because I can simplify that fraction. I want us to simplify the fraction. X squared minus 4, remember, we could factor as x plus 2 and x minus 2, right? Yeah. To there? Yeah. Okay. So, one of these, this x minus 2 here, I could cancel with one of these x minus 2's because there's 3 of them. All right? So, if I've got x minus 2 cubed means this, right? If I factored it. So I could do this. So I could simplify that fraction. So when you condense and you've got something you can simplify in the fraction, you should do that. So the x plus 2's in the top still, and the y cubed. And then in the bottom, I only have 2 x minus 2 instead of 3. So you would be expected to see that, to get it fully condensed. Okay? So you're going to have a few of those types of problems. Expanding and condensing. Questions? Addition, you change to what? Multiplication when you condense. Subtraction, you change to division. If you're expanding, when you see multiplication, you change to addition. When you see division, you change to subtraction. If you see exponents, you move them out front, Holly. Can't quite get it all. I'm writing too big. Get it all on there. Anybody else, question-wise? Okay, the last thing is that going over that change of base. Braden Baluch, what do I put in my calculator to get this answer? Where's the log 3 go? Top or bottom? No. Basement, right? The base goes in the basement. All right? And then whatever that equals. Okay? What about this side, Jake?
Log, and it's got 12 on the bottom.
Yeah, on the bottom, so the 400 is on the top. Okay, so that's just calculator stuff. Okay? You have some of those. We good? So the condensing and the expanding is going to give you a little trouble. It does every year. But practice it. Do your homework. It's not that much. Got an extra day to get it done. You don't have to come Monday, right? You should come Monday night, though, to watch us wrestle. Perry. I don't know. Maybe. Seem like simplified? Yeah, I guess.